two functions to intersect, you just say, well, they're equal to each other. So when does sine of 2 theta equal cosine of theta? And here's where those trig skills come in. So we need to get this to just be a theta, not a 2 theta. Consequently, we need a trig identity for sine of 2 theta, which is 2 sine of theta times cosine of theta. It might be tempting to say, oh, just divide by cosine and cancel them. If you do, you're going to be throwing away, possibly be throwing away half of the answers that you need in this problem. So instead of dividing, it's always a bad idea to divide by a variable. One reason is you're throwing away some answers you might need. The other is you might be dividing by 0, which is never legal. So instead, move the cosine over to this side. So subtract that from both sides. Now it's set equal to 0. Now you can factor it. So cosine of theta gets factored out. Then set each factor equal to 0. So we're going to have when does cosine equal 0? And then this one is going to say, once you move the 1 and the 2 over, when does sine equal 1/2? So on the left-hand side, just take a look at the cosine graph. Cosine is equal to 0 right here and right here. So this is going to be at pi over 2, and this is going to be at 3 pi over 2. And then we've got theta equals pi over 2. Theta equals 3 pi over 2. For this one, it says take a look at the sine graph. And then, where is that equal to 1/2? So at the top would be 1, 1/2 would be right here. If you use sine inverse, take sine inverse of 1/2, making sure we're in radians, then it's going to be this decimal. And of course you look at that and say, obviously that's pi over 4. If that's not obvious, what you can do is divide by pi, go to math, have the calculator change it to a fraction, and then it will tell you, oh, that's not pi over 4, actually that's pi over 6. So we've got from the calculator this right here is pi over 6. There's going to be another answer if you go straight across. There's another answer where it's equal to 1/2 right here, and that's just to the left of pi. So because this thing is symmetric, if this is a length of pi over 6, we have to go to the left by pi over 6, which means that it's pi minus pi over 6, which is 5 pi over 6. So then we've got theta equals on this side pi over 6, theta equals 5 pi over 6. So there should be 4 places, or 4 times, when these intersect. And then of course graph to verify. So we go to y equals, we've got sine of 2 theta. The second one is cosine of theta. And then 0 to 2 pi. These only range between -1 and 1, so -1 and 1. So one of them is making this 4-petaled rose, it's called. Even though it doesn't look like a rose, that's what it's called. And the other is making this, which is either a circle or an ellipse. It seems that there's 1, 2, 3 places where they intersect. And we got 4. Let's see. How about pi divided by 6? That's a keeper. Pi divided by 6. And the directions say actually find the points. So there's the point, x comma y. So that's going to be 0.75 and 0.433. There's one point of intersection. How about the 5 pi over 6? 5 pi over 6. That's a good one. So it's going to be 0.75 and negative 0.433. What about the origin? I mean the pole. So if you try pi over 2 and 3 pi over 2, pi over 2, that seems like they're intersecting there. Let's see. Right now, I'm on the function sine of 2 theta. If I jump it up to the other function, is it still in the same place? It seems like it is. It's surprising. So let me do one other thing. I'm going to turn off the axes. I'm going to slow it down. And then I'm going to graph them simultaneously. So that's under mode. And the thing is, for these to actually be intersection points, they have to get to the same place at the same time. So watch and see if it gets to like this point and this point at the same time. So graph them, those two, that's intersecting at the origin, and that's intersecting. So there's 3 intersection points. So for example, right there when it went through the origin that last time, it did not intersect the same place at the same time, but it did earlier, so that still counts. So then from these, we have the origin as well.